electric field inside the conductor is 0. Inside the conductor is 0. The electric field inside the conductor is 0. If I will consider a neutral conductor, what do you mean by conductor? A large number of pre-charge carriers exist. If I will consider a neutral conductor, it means equal number of positive as well as negative charges. And if I placed this neutral conductor in an external electric field, what will happen? The positive charge always trying to align along the direction of electric field. So positive charge will accumulate in these sections of the sphere, and negative charge always accumulate opposite to the direction of the sphere, opposite to the direction of electric field. So what will happen? Due to this positive and negative, an induced electric field will be set up. This induced electric field exactly opposes this external electric field. That's why electric field lines cannot penetrate inside the conductor. So electric field inside the conductor is 0. This is the first point student has to be in the mind, that electric field inside the conductor is 0. If the electric field inside the conductor is 0, we know a relation that E equals to electric field with potential relation, that E equals to minus dV by dr, and this dV can be written as what? Minus E dot dr. It will be written like this. If electric field inside the conductor is 0, can I say this potential, change in potential, is nothing but 0? So it is very obvious that the potential remain constant inside the conductors. This is a major property. So potential if constant, then can I say this behaves like an equipotential surface? Yes, conductor behaves like an equipotential surface. What does it mean? It means if I will consider a conductor is here, each and every point, if I will consider inside or on the surface, the potential remain same, because conductor behaves like an equipotential surface. If conductor behaves like an equipotential surface, here one student can predict that dV can be written as minus E dot dr. E and dr, this dV can be 0 also. E dr, it can be written as cos 90, because A dot V can be written as AB cos theta. E dot dr can be written as E dr cos 90. So in that case, what will happen? This dV also coming down to 0. It means in an equipotential surface, the electric field lines going out always perpendicular to the surface. This is a very major property, has to be remembered. If the field lines are coming out from any conductors, they always perpendicular to the surface of the conductors. The field lines always perpendicular to the surface of the conductors. This is major point. One first I will make revise like this. Electric field inside the conductor is 0. Why 0? Because if you placed a neutral conductor in front of external electric field, an induced charge, induced electric field will be generated, which is exactly opposes the external electric field. That's why electric field line cannot penetrate inside the conductor. That's the electric field inside the conductor is 0. If the electric field is inside the conductor, it is 0, then potential remain constant. It means the conductor behaves like an equipotential surface. If this dV can also be 0, if E dr, the angle between dot product cos 90, it means it is obvious that in an equipotential surface, the field lines, those have been going out always perpendicular to the surface. This is a major point a student has to be remember in the mind. And the fourth point, as there is no field lines inside the conductors, so charges always resides on the surface of the conductors. Charge always resides on the surface of the conductors. Surface of the conductors. If I will give conductor a certain amount of charge to the conductor, so what will happen? This charge will be lies on the surface of the conductors. This is a property of the conductors. Let me think some more properties. This is my neutral conductor, spherical conductors, and I placed a charge q which is having certain distance from the center of the conductors. Certain distance it is. Let that point is A. The question can be framed, what is the electric field due to induced charges? What is the electric field due to induced charges? This is my neutral conductor. If you observe very carefully, this is a positive charge. Due to positive charge, the field lines have been radially outward. It will be go like this. The field lines will be radially outward and it will be go like this. So due to that, there will be a charge accumulation on both the sides of the spherical conductor. Here negative and here it is what? Positive. So these are the induced charges, I can say, because the field inside it is generated, that is the induced electric field. So these are the induced charges. We know that electric field inside the conductor at point A is 0. This electric field due to how many charges? Due to this charge and are these induced charges. So can I say this electric field at A is nothing but electric field due to the charge which is exactly outside plus electric field due to induced charges. This is pretty obvious. So this electric field inside the conductor is 0. That's why E due to outside charge plus E induced is nothing but 0. Can I make my statement that E induced is negative of E external? This Q charge is outside, that it can be written as what? E external. So this is a very important relation. Some of the cases these questions usually come. This induced electric field is nothing but equal and opposite to what? Induced electric field equal and opposite to that external electric field. This is a major property of the conductor. Usually student little confused regarding this. If I will place a conductor to a certain distance, a charge is placed, what will happen? This due to this charge, the field lines will be go likely. This it means this simply this conductor is in an external electric field. What will happen? The induced charges will be accumulated on both the sides. Due to that, the question is asking. Question is here that at electric field at point A is 0 because it is inside point, and EQ plus E induced it is 0. So similarly we concluded, this is very important, that induced electric field is nothing but the negative of what? External electric fields. This is one major property a student has to be in the mind. If I will go to number 6 property, this is which property already covered, property 5, come to property 6. Some cases, usually these questions is asking, and it's a very general, obvious in most of the books, this kind of questions are given like this. C is a point, B is a point, and suppose A is a point. The distance from point A, this distance is treated as the distance D, and this is a neutral conductor. This is a neutral conductor, and here one charge small q is present here. The question will ask you, find the potential at point B. Find the potential at point B. We know that potential of B and potential of C remain same because conductors is an equipotential, behaves like an equipotential surface. So potential of C is nothing but potential of B. The question is asking for B. I will go for potential of C equals to potential of B. What is the potential of C? The potential of C, if I will go for this point, potential of C is due to potential of Q plus potential due to the induced charges. Potential due to the induced charges. This is very important. Potential due to which charges? Induced charges. But if you observe very carefully, these induced charges are symmetrically present on both the sides. If positive charge, potential is something, the negative charge potential, both will be cancel each other because neutral because they are neutral and they are symmetrically placed on both the sides of the sphere. So due to induced charges, this potential is 0 because both the distance remains same from these charges. And second most important thing, this potential of C is nothing but potential due to this charge Q. And what is the potential due to a point charge? This potential due to a point charge is nothing but kq upon d, or 1 by 4 pi epsilon naught q by d. This is very important, that electric field due to a point charge is kq upon r square, and potential due to a point charge is kq upon r. R is which distance? This distance, so kq upon d. So potential of C is nothing but potential of B. So directly I'll get potential of B is what? kq upon d. This is a very basic fundamental type questions. In the same questions, one more time I want to repeat to student perspective. A, B, C, some 3 points have been given. A point, a charge Q is present. Question is asking, write the potential of B. The potential of B is nothing but what? Potential of C, because conductor behaves like an equipotential surface. And potential at C is due to how many charges? Charge due to this and charge due to induced charges. But due to induced charges, potential is 0 because they are equidistant, symmetrically arranged on both the surface of the sphere, neutral conductors. So that's 0. Only C potential due to this point charge, and what distance it is lies? D distance. I will write the expression of point charge, and this C is nothing but B. I will simply get the potential.